And welcome back to another LeetCode video. Today we're dealing with 152 maximum product subarray. This is a classic one-dimensional dynamic programming problem that we're going to solve today. So let's look into this. What is it about and how to solve this? We're given an integer array of numbers and we should find a subarray that largest product and return the product. And if we look at the examples, you can see that they are both positive and negative numbers inside the subarray. So dealing with negative numbers and zeros are going to be cases that we need to consider. Now, if we look at this first example, we have the numbers 2, 3, -2, and 4. And obviously, the product of 2 and 3 is the maximum that we can get. We can also consider the individual numbers in this array to be valid subarray sum or subarray products. However, none of them are larger than 6, so this is why in this instance 6 is the result. If we were to extend the array that goes from 2 to 3 to -2, obviously that flips to -12, which is no longer a large one. However, if there was another negative number later, that would flip that scenario again, where we end up with positive product all. In that case, the entire array would be the largest subarray that yields the largest subarray product. There's another example here where we only have negative numbers and 0. Now, -2 is smaller than -1, which is smaller than 0. And even if we multiplied all of the elements in the array because of 0, we're not going to reach a positive value. So the maximum value that we can get is actually 0 in this. So how do we deal with this? Well, the brute force approach should be quite obvious. In the brute force approach, we would just iterate over all of the possible subarrays. And just for the sake of completeness, I'm going to show you how to do that. We're going to need two nested loops that are going to take O of n squared time. And we don't need any additional storage, so we will get away with O of 1 space. The O of 1 space is going to be for our result variable. And we'll update as we iterate through the array. And we're going to initialize it with -infinity so that when we compare our result variable with the current product and pick the maximum product, update our result variable. So at the end, we're going to return the result. And in the middle, well, we need our two nested for loops to have the left side and the right, the left index and the right index of the subarray that we're considering that numbers. So for left in length of, and the same for the right one starts at left. And there's always the danger of having off by 1 errors here. And we're just going to keep track of the product of all of these numbers. Right, so we start with the product of 1, so that when we have an array where left and right is the same, for example, consider a subarray from 4 to 4, we want this value to be 4. So that's why we initialize product with 1. And then we just multiply that value with value of numbers at position. And at the right position, right? So these two nested loops, they're going to give us all of the combinations of left and right that we can have. Actually also not going to complete any duplicate subarrays with this because we're always advancing the left pointer, and then we iterate with the right pointer over all of the array, building up our product. Now in the inner loop, what we'll have to do is we'll have to update our result variable, and that's now going to be the maximum between the current result and the product. It can be that the product becomes 0 if we run into a 0 value, but that's fine. So if we, for example, compute this product between 1, obviously it's going to turn 0 at some point. However, at a later point, when our left pointer reaches the space of the line 0, we will start building a new array that starts at 1 time. So nothing is lost. And we've successfully circumvented the issue of running into zeros. Now, This is obviously not the most efficient approach, and if I were to submit this now, I think we would also run time limit exceeded exception simply because this approach is too slow. Well, question is now, how can we solve this in a more efficient way? And turns out there is another way, which is linear, and also requires only constant space. Now, in order to understand these tricks, we're going to reuse one idea from our previous solution, which is that we don't care if we run into a 0. All we need to care about is that build a new product after we ran into a 0. So that is something that you will see in the optimized solution. And another trick that the other trick that we're going to use is, well, how to deal with negative numbers. Well, if we were just to go and multiply these values together in this array, we'd have 2 times 3, which is 6, times 2, which is 12, times 4, which is 48. If we now run into another negative number, that would immediately flip. So if we run into a 2 at the end, we would immediately flip the product to positive 6. Right. So we want to capture that. And instead of counting the number of negative numbers or anything, there's a nice elegant way that we can just iterate through the array in linear time. And we will do something special whenever we encounter a negative value. And the trick is that we keep track of both the maximum product as well as the minimum product. You imagine you had a maximum product at 40 and the minimum product is 20. Now, when you run into a minus, say a minus times -1, this would flip immediately to the minimum product being -40 and the maximum product being 20. So we're still able to go and to get the maximum product from our two products that we have. We just need to keep track of the minimum and the maximum one. So even if the array consists of only negative numbers, there's it only consists of negative numbers, we will constantly flip back and forth in switching the maximum and minimum one. But if we only contain one negative number, for example, or 3 negative numbers, we will have well, 1 flip or 3 flips, and we will still be able to compute the correct result. Right, so in this case, we're going to do the same thing where we first initialize the result variable, I should say in this. And well, like I said, we're going to keep track of the min product and the max product. We're going to initialize them with the value of 1. Now we just need to iterate over the numbers. We don't care about the index. And well, we have to check if the number is smaller than 0. If that is the case, we're going to swap products. So we will do Python this variables like so. Right, so now the min product becomes the max product and the max product becomes the min product. Right, so now how do we update these products? Well, for our min product and for our max product, obviously have to, we obviously have to multiply them with the value n, right? Now we could do that, but then if we run into a 0, then the product becomes 0 and stays 0 for all the rest of the array. So what we will do instead is, and now there comes the idea back into play where we recover from a 0 by only considering the product starting at the index after where we counted the 0. And the trick that we're going to use is we're going to use the minimum between a value n and the previous and the min product times the current value of n. So this little trick has the effect that if n is equal to 0, the minimum is going to go to 0. But in the next step, when we have a value of n that is unequal to 0, right, we're going to pick that value. And if it's smaller than 0 for the minimum, but we're also going to pick that value when it's larger than the current value of the product, which is 0 times whatever the number is. So this little trick resets our 0 product with the next number, not 0, and which is the same as starting with the product new. Right, and you can see that in terms of, by the way, this is the entire code, and you can now see that we are only iterating one time over the array, or we need to keep track of our 3 variables, so that's definitely the case. And if we run this, see that it works. Oh, I forgot one important thing. Obviously, we need to update our result variable. And now our result variable is going to be the, well, we're not going to use the min product to update our result, because we know min product is always smaller than max product. But we're going to need to update it if max product is larger than. Right, so we're passing the 2 test cases that we've discussed before. And if I submit this now, we should see that it passes all of the tests. And yeah, and the interesting thing is that, oh, the dynamic programming problem. Turns out that there's, I think, a more efficient solution. Just consider this as array traversal. Either see it as a 2-pointer product where you go over all of the combinations of left and right, or well, if you have side, then you can come up with a simpler solution, a more elegant, find overlapping sub-problems and deal with all of that. Whenever you encounter problem, and even if you know that's a dynamic programming one, don't be shy to look maybe for other solutions. I find this solution much more intuitive. But yeah, you decide for yourself how you're going to implement this. I hope you found this interesting.